Okay, now I'm on A.
Yep.
Okay, are we good now?
Yeah.
Okay, here we go. Okay, so here we've got this LDL, right, this lousy cholesterol. That's the bad cholesterol. And it says that it wants it less than 130 milligrams per deciliter. All right. Now, here's what it says. It says on the average, a human has 4.7 liters of blood. What is the maximum number of grams of LDL that a human should have in their whole entire body? Okay. So 4 liters of blood, right? Now we got liter and deciliter. We're going to put a 1 there. Why? Because it's 2 letters. Okay, now liter, what goes here? 1 times what? -1? Okay. Where did I get that from? The table. See how that liter just goes by. All right. Oh, okay. I misread that. 4.7 liters. Okay. All right. What's that now? Deciliters. Okay. So that's what we got there. All right. Now 4.7 liters, and we have now converted to deciliters. Now, what is desirable? Well, desirable is 130 milligrams per deciliter. So the deciliter's gone bye-bye. All right, what's that now?
Is the 1 times 10 to the negative first, that's right?
I think. Let me check.
That's what I was asking.
Let me check myself here. Deci 10 to the minus 1. Yes, that's right. Okay. So this right here will give you your final milligram answer. All right. For this particular problem here. So 4.7 divided by 1 times 10 to the minus 1 times 130. All right. So 4.7 divided by 1 times 10 to the minus 1 times 130. So that'd be 6,110 milligrams of lousy cholesterol in your whole entire body now. Okay. Your whole entire body. Is that what you got? Good.
You add it in again in your calculator. 4.7.
Divided by.
Yeah, it's in grams.
Oh, they want it in grams or they want it in milligrams?
Grams.
They want it in grams. Okay. So we're going to take the milligram here. All right. 1,000 milligrams in 1 gram. So that's going to be 6.11 grams. Yeah? Is that what you got?
Yep.
Okay. So now what you got? We got you cleared up on the calculator? Oh, we're good. Okay. Okay, number 67. How'd that work for you? Good. All right. Well, then let's try another one. 40. Is that what we want to do next? It says oil spreads in a thin layer on water called an oil slick. All right. And here's what it wants to know. It wants to know how much area in meters squared. So this is going to be meters squared, and that is a measurement of area, right? Like if you buy carpet, you buy a square foot of carpet, or a square foot of this or that. They're talking about a length times a width. Well, that's what this oil slick's talking about. It's a length times a width. So it wants to know the area in the meters squared, and here's the story. It says that if you take 200 milliliters of oil, and the layer is going to be 0.5 nanometers thick. All right, so let's talk about this. Okay, we're taking a beaker of oil that has 200 milliliters in it. Remember, a milliliter and a cubic centimeter are exactly synonymous. We're going to pour that out. It wants to know what the area is. All right. Well, first off here, if we take 200 cubic centimeters, okay, what are we going to do? Well, if we can divide that by a thickness, we will get an area. All right. So can we just put 0.5 nanometers here? No. You see how nanometer and centimeter, that ain't going to go. All right, so again, it's the problem of unit consistency. All right, so what I would do now is go over here on a tangent and try to convert 0.5 nanometers to centimeters. Well, here's what I know. 1 nanometer is the same thing as 1 times 10 to the negative 9th meters. All right. Now, 1 centimeter is 1 times 10 to the minus 2 meters. Are you with me? So now I'm done. See, I've got my unit consistency. All right, so here's what we got. We got 0.5 times 1 times 10 to the negative 9 divided by 1 times 10 to the minus 2. Hit the inner bucket for 5 times 10 to the minus 8 centimeters. This right here is the thickness of that oil slick. So we got water. We've threw out the oil. It's in a very fine layer on top of the water. Okay. Remember, I told you most organics floated. Oil's an organic, it floats. All right. Right, like you remember the guy, when did that happen? Back in the 90s, right? The Exxon Valdez guy that wrecked the big boat. You guys don't remember that big oil spill? Well, one person shaking said, some of you guys may not. It hadn't been that long ago. So anyway, okay, so what's the area there? Well, what if we just divide this? What if we just say, boom, let's divide that by 5 times 10 to the minus 8 centimeters. Well, what's going to happen? That centimeter is going to completely go, right? And this will change from a centimeter cubed to a centimeter what? Squared. Now, it wants the unit in meters squared. So what are we going to have to do? All right, 1 centimeter is the same thing as 1 times 10 to the minus 2 meters. Now, will this and this completely cancel? Huh? No, what do we have to do? Put a square up here, right? Now we can make that completely go bye-bye. So, 200 divided by 5 times 10 to the minus 8 times 1 times 10 to the minus 2 is what? 4 times 10 to the 1, 2, 3, 4, 5, 6, 7. Do I have a second on that? 4 times 10 to the 7th. Is that what you're getting? Yeah. You didn't get that? You got that. You didn't get that.
I didn't get it right, but the book says it's 10 to the 5th.
10 to the
I
5th.
had it wrong and then I figured it out.
Okay, well, let me be sure I've tapped everything in right.
Book could be wrong.
It could be wrong. I mean, that's true. That does happen, by the way. All right, I just want to be, before I start being show-off, I want to be sure that I've not messed up. All right, because, you know, I can certainly mess up. So, well, volume equals area times height. So if I divide by the height and divide by the height, that means that my area equals volume divided by height. I've did that. Fine. So I'm happy with my formula. Now, I found it. Okay, a common mistake you guys are going to do. You know what I didn't do? Is I didn't square that. So let me just hit the exact same answer squared. And now I'm getting 4 times 10 to the 5th. Is that what the book's getting? Okay, 4 times 10 to the 5th. And again, you know, it may sound stupid, but I really do like making mistakes in front of you, because those are the mistakes that you might make on a test. Right? Think about it. All I did was forgot the square. I had it wrote down. I just forgot it. And on my test, if you do something like that, if this was a 10-point problem, you're going to get 9 of them points. The most important thing is getting this problem set up. Really, the least important thing is that final answer. I mean, that should be the last thing on your mind. Because in real life, you're going to have somebody check you. Or you're going to go drink a Coke and come back and do it again.